Okay, so what we're going to be doing today is we're going to be analyzing the different forms of the quadratic equations. We're going to be looking at the vertex form, which we covered on Monday, the standard form, which we talked about yesterday, and then the vertex form, which we very briefly addressed when we converted from standard to intercept form. Let's start off with the vertex form. So the advantage to the vertex form is that it's easy to find the vertex. It's easy to find the vertex. Why? Because the vertex is your H and your K. Some people say that the vertex is found at change the sign, keep the sign. So let's look at an example. If I have an equation that says y equals x minus 3 squared plus 5, I know that my vertex is found at the point, change the sign, keep the sign, 3, 5. What does that mean? What does it mean that we have a vertex at 3, 5? That means that we have a parabola. We know it's a parabola because it's squared, that has a minimum value at 1, 2, 3. 1, 2, 3, 4, 5. That's your vertex, 3, 5. And that's what it's talking about. Where is that value where you have a bottom value, the minimum value? Or if it's a parabola that concaves down, what's the maximum value for a concave down? Any questions on that one? For the next one, there's a couple of advantages. So for the first advantage, it's easy to find the y-intercept. It's easy to find the y-intercept. Why? Because it's always c. Whatever this number is right here, that's your y-intercept. It's equal to c. Now, the next advantage I have not talked about yet, and it's something that you want to use during your ACT. So we're going to look at A and B, whatever these two numbers are, and if A and B are the same sign, the parabola will translate, it'll translate to, it's going to move to the left. going to move to the left-hand side. And what do I mean by move to the left-hand side? Remember that the parent function of a quadratic equation looks like this, right? That's a parent function, y equals x squared. So when A and B are both positive or both negative, it's the whole thing, this green line is going to move to the left. If they're different signs, so if A and B are different sign, the parabola will translate to the right. So let's look at an example. If I tell you that y equals 3x squared plus 4x plus 1. Well, there's two things I can tell from this graph right away. So I'm going to sketch. I know that for sure my y-intercept is 1. I know that for sure. And because A and B are both positive, this green line is going to move to the left. So I'm going to put my 1 right there, my y-intercept of 1, and I'm just going to sketch. I know that that vertex moved to the left. Again, that is just a sketch. We'll talk about, after the holidays, we'll talk about all the other possibilities that exist there. But on the ACT exam, that will give you your answer. Or on the SAT, on the GRE, on the standardized exams. Now, if this would have been a negative, if 4 would have been a negative, it would have moved to the right instead of to the left, like it is here to the left. Questions as to what I mean by translating to the left or to the right? The intercept form. As I mentioned yesterday, the confusion about this one is that it doesn't say which intercept. Here, so for clarification, we're going to make a clarification first. When we're talking about intercepts, we're talking about the x-intercepts. In other words, the solutions to the quadratic, the real solutions to the quadratic. So the advantage to this is that finding the solutions will be easy. That's the advantage. Finding the solutions, finding the zeros, finding the x-intercepts. are easier to find. Why? Because they're found at x equal to P and Q. At P and Q. But also you need to understand that they're found at P and Q when y is equal to 0. So what you have is you actually got two coordinates. You got the coordinates P comma 0, and you got the coordinates Q comma 0. So we'll look at an example. If you have an equation that says that y is equal to 3x minus 2 and x plus 5, we know that the graph is going to be crossed through the point positive 2, because you change the sign and change the sign. 1, 2. And if you looked at yesterday's notes, it gives you the details on this step. For today, we're skipping steps. And we change the sign. Negative 1, 2, 3, 4, 5. So we know that it crosses through those 2 points. To find the y-intercept, so these were the x-intercepts. To find the y-intercept, again, I'm skipping a lot of steps here. You either let x equal to 0 and solve for y, in which case you're going to have 3 times negative 2 times 5. Which gives you negative 6 times 5, which is equal to negative 30. That's the y-intercept. So now let's talk about the line of symmetry for each one of these cases. The line of symmetry. For this situation, that's your line of symmetry. It goes right through that x value. That's your line of symmetry at x equal to 3.
Do you have a bake? Can you see?
That was my son. And on this one right here, the way you find the line of symmetry is you count inwards. 1 in, 1 in. 1 in, 1 in. 1 in, 1 in. Halfway in, halfway in. That's your line of symmetry at negative 1.5. X equals negative 1.5. Now this one's a little bit harder. To find that line of symmetry, you have to say x equals negative b over 2a. And that can be found in previous notes. So make sure to look at those details. All you do is you substitute negative 4 over 2 times 3, which is the same thing as 2 over 3. So see, this line of symmetry was actually closer over here this way. That's why I was saying that's just a sketch. So we just analyzed each different form according to their advantages.